All right, we're going to continue reviewing, and I'm now moving on to graphing trig functions. And I just wanted to look at one of those, like number 29. Okay, and it was -5 secant x plus pi over 4. Okay, so first thing I'm going to think is that I'm going to start by graphing y equals -5 cosine x plus pi over 4. And I'm going to focus first on getting the 5 key points. So I'm going to take that part inside there, and cosine and secant both have a period of 2 pi. So for cosine, I'm going to set it up between 0 and 2 pi. And I'm going to adjust, and we'll see what happens here. So when I get the x by itself, I have to subtract pi over 4. And when I do, remember you're subtracting that from all sides, all parts. So that's 8 pi over 4 minus 1 pi over 4 would be 7 pi over 4. All right, now this particular one wound up just shifting, having a phase shift. This is the phase shift. This is the new starting point. Okay, it's going to be to the left a little bit, but it still has a period of 2 pi. The difference between these is still 2 pi. So it still takes 2 pi in order to complete your full cycle on your cosine graph. Okay, so let me go ahead and get this set up. So let me just get my pi, 2 pi on there. Let me go back to negative pi. And when you're doing your 5 key points now, it's going to start at negative pi over 4. It's going to end, one rotation ends at 7 pi over 4. And then to get the halfway point, we looked at how you could add these and divide by 2. So 6 pi over 4 would be what you get when you add them. 6 pi over 4 divided by 2 would be 6 pi over 8, and that's 3 pi over 4. So halfway in between is 3 pi over 4. Then I really want to split each of those in half to get the 2 values in here. Okay, so negative pi over 4 plus 3 pi over 4 would be 2 pi over 4. And if you cut that in half, that's going to be 2 pi over 8. Okay, I might show that what I'm doing there better. If I want the halfway point, I can use the midpoint formula. Negative pi over 4 plus 2 pi over 4. Okay, all divided by 2. So that would be 2 pi over 4 divided by 2, which is 2 pi over 8. And then that means this right here would be pi over 4. Okay, and then halfway between these might be a little easier because see how it goes from 3 pi to 7 pi? So you might be able to tell that that's going to wind up being 5 pi over 4. It's going to be 10 pi over 8, but it'll simplify down to be 5 pi over 4. All right, so we did that because those 5 key points are where the ordinary cosine graph. So like if I looked at cosine of x, it's going to do what cosine would have done if there'd been no phase shift. So it's going to, cosine, remember, is the one that starts at 1, goes to 0, goes to -1, goes back to 0, and then goes back to 1. And so things that typically happen are just going to be shifted to the left a little bit. So let me get these cut in half, and then each of those cut in half, since my key points involve denominators of 4s. Okay, so it's going to start here, and it's going to start at 1 right there at pi over 4, negative pi over 4. It's going to go to 0 at pi over 4. It's going to go to -1 at 3 pi over 4. It's going to go back to 0 at 5 pi over 4. That's like every 2 tick marks, right? And then it's going to go up to 1. So that's 5, 6. This would be 7 pi over 4. It's back at 1. So there's the typical looking cosine picture. Okay. And that's if I were doing just cosine of x. So now I want you to think about what happens when you put the 5 in there. I'm going to do that in blue. That just means that you're going to be not at 1. You're going to be at 1, 2, 3, 4, 5. You're going to be up here at 5. But rather than being at positive 5, it's going to flip across and be down here at negative 5. So you could combine those if you wanted into 2. Or I'm going to go ahead and do them separately. So the 5 by itself would stretch your graph vertically. These would stay at 0, but these other pieces, 1, 2, 3, 4, 5, would go and be 5 times as far away from the x-axis. So that would be y equals 5 cosine x plus pi over 4. Then if I wanted it to be negative 5, that's going to take all of those and flip them to the other side. So that would be there. This would still be at 0. This would now be up here at 5, still at 0, and then down here at negative 5. So it would have that same look, but be flipped over. Okay, so this guy is y equals negative 5 cosine x plus pi over 4. Okay. All right, now here's what I want you to think about. Go ahead and graph the cosine graph first. And I wish I had a little more space above there. I need you to be able to imagine it so I don't have to redo this video. Imagine this extending up a little bit more and this continuing on down further. All right, the relationship between cosine and secant is that they're reciprocals of one another. So to do the secant, you have to do 1 over the cosine. And so if the cosine graph is 0 right there, when you do secant, it's going to wind up being undefined. Okay, and so I'm going to do that. And then the green one is what I really need, except for I need it to be secant. So what I'm going to do then is where that is, that's where those little u's are going to be. Oops, I just said the green one and then I drew it on the blue one. Where the green one is, that's where the u's are going to be. So it's going to come in and be a u right there. Can you imagine it without me having to redo that? Okay, and then see this would continue. Okay, so it would go 0, okay, here, and then it'd be back to 0 and another 2. So it'd do something like that. And then it'd be back up like here. So you'd have another undefined, another asymptote right there. Okay, if I got that right. Let me see if I got that in the right spot. It's supposed to be 1, 2. Nope. I got it over too far. It'd be right there. Okay, so it'd do something like, get that out of the way. Okay, so it's over here and then there. All right, that's where it's going to hit 0 again. So it'll come back like this. Okay, and then it'll go back up. All right, so there's going to be another asymptote right here, and you'd have another u right there. You'd have another one over here. You'd have another one up here. Okay, and so what you're seeing in red here, remember this, that's the y equals negative 5 secant x plus pi over 4. Okay, so usually I kind of think through a progression of graphs to do this, and hopefully there'll be a coordinate plane for you to use on the test. All right, and then you can do the other graphing ones. All right, the part that I feel like people may not have fully understood without having some back and forth in a class setting would be the problems involving inverse functions. See, this is an issue of composition of functions if you had 112 recently. And so you would think that tan inverse of tangent of 3 pi over 5 would just be 3 pi over 5, that these would undo each other or cancel each other out. But the problem is that when you do tan inverse of something, it gives you an angle that's, the angle's got to be just in the first or the fourth quadrant. It's got to be between negative pi over 2. So this, the answer to this has to be between negative pi over 2 and pi over 2. Okay, and 3 pi over 5, that's over here. 3 over 5 is more than halfway to pi, so it's a little bit over here. This would be 3 pi over 5. Okay. All right, so this is trickier than you think. So here's the thing. You need an angle that would have the same tangent as that, okay, which would be actually over here. And see, this piece right here, if that's 3 pi over 5, and this is 5 pi over 5, when you get there, that means in here you have 2 pi over 5 as your reference angle right here. And so here's the angle in the fourth quadrant that would have the same tangent as 3 pi over 5. And this angle right here is 2 pi over 5. That amount right there in red, that's 2 pi over 5. But I need it to be the negative 2 pi over 5. So the answer to 32 should be negative 2 pi over 5. It has the same tangent. The tangent on both of those would be a negative number. But when you do tan inverse, it's defined to be an angle between negative pi over 2 and pi over 2 that has the tangent equal to this. All right, so you got to be careful when you do your drawings. All right, let's try 33. I'm going to do several of these. Look at 33. On 33, we have to do the inverse cosine of the cosine of 7 pi over 6. Okay, so let's think about where 7 pi over 6 is. All right, this would be 6 pi over 6. 7 pi over 6 is just 1 pi over 6 past that. Okay. All right, now the reference angle, there's all these reference angles that have a pi over 6 as their reference angle, all those angles. Okay, so when you're thinking about what would happen if you did cosine inverse of the cosine of 7 pi over 6, it can't be 7 pi over 6 because cosine is going to have to be an angle in the first or fourth quadrants, an angle from 0 to pi. Okay, and so you can't use 7 pi over 6. It's too big. So what you need is an angle that would have the same cosine. Okay, so they have to have the same reference angle, and then they have to have the same SIGN. They have to both be positive or both be negative. So if you're dealing with 7 pi over 6, this would be the angle that would have the same cosine. Both of those would be negative. And so you have to think about, okay, so that would be 5 pi over 6. Both of these have a reference angle of pi over 6. So the numerical value of the cosine would be the same. Okay. And it would be, by the way, square root of 3 over 2. But since they're to the left, they would both have a value of negative square root of 3 over 2. Right? You don't really need that value. You just need to understand that the answer to this question is really 5 pi over 6, not 7 pi over 6. These don't just cancel each other out. You have to think about that issue of making sure you're reporting back an angle that's within the allowable interval. Okay, so it's not easy. All right, let's look at 34. 34 has you use different ones. This time on, let's see, 34 was doing the cosecant of the tangent, tan inverse of square root of 3 over 3. Right, and they don't want you just using a unit circle or using your calculator. It says use a sketch to find it. So I wanted to show you what they're talking about there. All right, so first, the tan inverse of something. This is an angle, is what you should be thinking. And then you need the cosecant of that angle, but you never need to know what the angle is. You just need to think about where it's located and what the parts of the triangle are going to look like. Okay, so since this right here is positive, since you're doing the inverse tangent of a positive number, the inverse tan is going to report back an angle between pi over 2 and negative pi over 2. So an angle over here. And if the tangent is positive, it has to be an angle in the first quadrant. Okay. So I'm going to draw that, but I'm going to drop that perpendicular to the x-axis, and I'm going to use these to label it. So tangent is opposite over adjacent. So that's square root of 3 over 3. And I'm not trying to do and figure out the angle. I don't ever need the angle. I just need to use my sketch to figure out cosecant. All right, so cosecant is related to sine. I know I'm going to need the hypotenuse of that triangle, so I'm going to work on that. So I want this piece right here, the r. And I know that's going to equal 3 squared plus square root of 3 squared. So that's going to be 9 plus 3, which is 12. Okay, and so r is going to equal the square root of 12. And I may not rationalize that till I get near the end, till I see what I wind up with. So this is square root of 12. You know, or I might have to simplify that is what I meant, but I don't want to do it quite yet till I kind of see what's going on. All right, so I can think about cosecant outright being related to sine. Sine is opposite over hypotenuse. So cosecant would be hypotenuse over opposite. So that's okay to do. Or you could do the sine first and then take the reciprocal. So you could be thinking the cosecant of an angle equals the, since sine is opposite over hypotenuse, this would be hypotenuse over opposite. And just go from there. So you know the cosecant of this angle would have to equal, do it in red here. Opposite is square root of 3, hypotenuse square root of 12. It would be square root of 12 over square root of 3. Oh, that's square root of 4, and that would be 2. So the cosecant would be 2. I never did have to figure out what the angle itself was, and it was intended that you don't do that. You draw the sketch to work through the problem. Okay. So this came from the one where we did a lot of graphing. You did that learning guide, and the inverse trig functions is the thing I really wish I could have had some talking back and forth with you to make sure you understand the key parts of it. But hopefully that reminds you enough about how to approach them.